Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day to everybody. Okay, so for today's lesson, we are going to proceed with coordinate geometry under the subtopic parallel lines and perpendicular lines. Okay, let's begin. Okay, our objective for today's lessons are, at the end of the class, you should be able to make and verify conjectures about gradient of parallel lines and perpendicular lines, and hence make generalization. Next, we should also be able to solve problems involving equations of parallel and perpendicular lines. Okay, let's explore. Okay, so from this diagram, we can see that we have a straight line in which the straight line joins points A, B, and A is coordinate x1, y1, and B is coordinate x2, y2. So, when we talk about gradient of straight line, we do know, in order for us to find the gradient of straight line, we need to find the ratio between the changes in y with respect to changes in x, in which m equals to y2 minus y1 over x2 minus x1. Okay, so as you can see here, okay, which part represent y2 minus 1? So y2 minus 1 represent the changes in y. So this is what we call changes in y. So changes in y represent by the side of B, C. However, x2 minus x1 represented by the changes in x. Okay, changes in x, which represented by sides A, C. Okay, so from that right angle triangle, we can say that y2 minus 1 is equals y2 minus 1 over x2 minus 1 is equals to BC over AC. So, okay, again, when we talk about right angle triangle, okay, two things that we need to be familiar of. Right angle triangle deals with one, Pythagoras theorem, and the second one, it deals with trigonometry. Okay, Pythagoras theorems deals when we have two sides and we want to find another side. But trigonometry, it deals with sides and angles. So as we can see from this right angle triangle, we have sides and angle. So we can say that BC over AC BC over AC, in which BC is also known as, let me use another color. Okay, where is it? Another color. Okay, BC is also known as opposite, and AC is the adjacent. Okay, so we can say that it is also opposite over adjacent. So in trigonometry, opposite over adjacent is called as tangent theta. So from here, we can say that M, the gradient, can also be represented by tangent theta, because we are talking and we are dealing with right angle triangle. Okay, so the definition of gradient M of a straight line is, silap pula. Okay, M equals to tangent theta, with theta being the angle formed between a straight line and the positive x-axis. 0 degree, the theta is between 0 and 180 degree. Okay, so it is in quadrant 1 and quadrant 2. Okay, next, parallel lines. Okay, from these diagrams, okay, we can say that, okay, diagram 1, okay, let's say this is 1, this is 2, this is 3, and this is 4. Diagram 1, line 1 is parallel to x-axis. Okay, line 1 parallel to x-axis. Meanwhile, line 2 parallel to y-axis. Line 3, it is an inclined line. So same goes to line 4. Okay, the difference is line 3, the line is in positive gradient. Line 4 is the gradient of the line is negative. Okay, so let's look at line 1. Okay, line 1, again, it is parallel to x-axis. Okay, x-axis. So we can say that the theta is equal to 0 degree. Okay, theta is equal to 0 degree. So tangent theta is equal to tangent 0 degree, which gives us gradient of line 1 is equal to 0. Okay, if you see the situation in which the line is parallel to x-axis, bear in mind the gradient must be equals to 0. Okay. However, for case 2, line 2 is parallel to y-axis. Okay, when we talk about parallel to y-axis, the angle is 90 degree. So we said that theta is equal to 90 degree. Therefore, tangent theta is tangent 90 degree. So when you use calculator, you will have math error. Why? Because tangent 90 degree is undefined. Okay, it's undefined. So we can say that, oh, the gradient of line 2 is not defined or undefined. Okay. Meanwhile, for case 3, line 3, okay, we can say that the angle is between 0 degree to 90 degree. Okay, the angle is between 0 degree to 90 degree. So we can say that tangent theta is greater than 0. Why? Okay, maybe you haven't learned trigonometric function, but you need to know, okay, we have 4 quadrant. Quadrant 1 is all. All means sine, cos, tangent, all must be positive. In quadrant 2, sine positive. Quadrant 3, tangent positive. Quadrant 4, cos positive. How do I know? Because I have been taught by my teacher how to memorize it is add sugar to coffee. Add, I use another color. Okay. Add sugar to coffee. So, another color. Add A. A stands for all. Okay, A stands for all. Sugar, S stands for sine. 2, T stands for tangent. Coffee, C stands for cos. So we can say that, oh, in quadrant 1, all the trigonometric functions should be positive. And then quadrant 2 only sine positive, quadrant 3 only tangent positive, and quadrant 4 only cos positive. So if we compare, okay, if we compare with case 3, okay, with case 3, we can say that, oh, this is in between 0 to 90 degrees. So we said, oh, this is in quadrant 1. In which in quadrant 1, tangent theta is positive. That is why tangent theta greater than 0. So this is where we can conclude that gradient line 3 is positive. Okay, can you follow? Okay, next. For 4, line 4, the angle is between 90 degree and 180 degree. So 90 degree and 180 degree, this is in quadrant 2. Okay, and before we said that quadrant 2 only sign positive, but gradient relates to tangent. So we can say that, oh, tangent theta is less than 0. It's negative. That is why we conclude that gradient line 4 is less than 0. Okay, can you follow, guys? Okay, next. Okay, so if we look at this diagram, we have line 1 and line 2 in which both lines are parallel to each other. Okay, are parallel to each other. So for line 1, we have angle theta 1 here, and for line 2, we have angle theta 2 here. So you have learned line and angles in lower form. So we have known that angle deals with parallel lines. We have 3 types of angle: correspondence angle, alternate angle, and interior angle. So this case is case correspondence angle. So this is the case correspondence angle, in which correspondent angle state that when line 1 parallel to line 2, therefore theta 1 is equals theta 2. So this one. So when we talk about gradient for each line, we are talking about the tangent theta for each line. So we said since theta 1 equals to theta 2, therefore tangent theta 1 is equals to theta 2. So we can conclude that, oh, that means gradient 1 is equals to gradient 2. Okay, gradient 1 is equals to gradient 2 because of what? Because both lines are parallel to each other. So when it is parallel to each other, the angle is the same. Okay. Conversely, if M1 equals to M2, we can find that theta 1 is equals to theta 2 and line 1 is parallel to line 2. So what I want to say here, what I want to conclude here, that if two straight lines are parallel to each other, if and only if its gradient are equal. Okay, we need to highlight this one. If L1 parallel with L2, therefore M1 is equals to M2. What does M1 represent for? M1 is gradient for the line 1. M2 is gradient for line 2. Okay, this is the most important thing. Okay, so parallel lines, you need to remember parallel lines will deals with same gradient. When we talk about parallel lines, you need to remember, you need to know that, oh, gradient 1 is equals to gradient 2. M1 is equals to M2. Okay. Next, let's look at example 1. Okay. Determine whether the following pairs of straight lines are parallel lines. Okay, we have 2 questions. Okay. Y is equals to negative 6x plus 1 and y equals to 5x plus 9. Let's look at A first. Okay. Okay, since we talk about parallel lines, so we said that if line 1 is parallel to line 2, therefore the gradient must be equal. So we need to fulfill this one. So the problem is we don't have our gradient. Okay. Can we have the value of gradient from the equation of the straight line? Of course, we can. But we need to form the equation of the straight line to gradient form. What is gradient form? Gradient form is y equals to mx plus c, in which m represent gradient, c represent y-intercept. So from this equation, of course, we can find the gradient. Okay, so from y equals to negative 6x plus 1, we can compare with this one. Okay, we can say that, oh, our gradient is negative 6. The same goes to y equals to 5x plus 9. So we can say that since the gradient is the coefficient of x, so the coefficient of x for the second line is 5. So we said that, oh, our gradient for second line is 5. So is m1 equals to m2? Of course not, because negative 6 is not equals to 5. So m1 is not equals to m2. So what can we say? Since the gradients for both lines are not equal, both lines are not parallel lines. As simple as that. Okay? Okay, let's look at B. Okay, as you can see, B, the coefficient of y is not equals to 1. Okay, so how can we find the gradient? Of course, again, we need to change it into gradient form. So you need to change it into y equals to mx plus c, in which the coefficient of y must be equals to 1. Okay, so let's look. Okay, so for the first equation, 2y minus 3x equals to 4. So from there, we can say that, oh, the gradient form is y equals to 2 plus 3 over 2x. Okay, since the gradient is the coefficient of x, so we can state that, oh, for line 1, the gradient m1 is 3 over 2. Okay, let's look at the second line. 6x minus 4y equals to 3. So from there, for y equals to 6x minus 3, therefore y is equal to 3 over 2x minus 3 over 4. Okay, in which we can say that, oh, the gradient is 3 over 2. So m2 is equal to 3 over 2. Okay, is both gradient is equal? m1 3 over 2, m2 3 over 2. So of course we said that m1 is equals to m2. Thus, since m1 is equals to m2, kita boleh kata, since the gradient for both lines are equal, thus both lines are parallel to each other. Okay, simple, right? For this question, simple. Okay, let's look at example 2. Find the equation of straight line which passes through 1, 4 and is parallel to line 2y plus 4x equals to 5. So, we are talking about find equation of straight line that passes through 1, 4 parallel. So, if we want to describe this in diagrams, so it's like we have this equation, this line 1, in which the equation is 2y plus 4x equals to 5, and we have another line in which the line is parallel to each other, but what is the equation? So of course, when we talk about equation of straight line, we need to deal with this equation, y minus y1 equals to mx minus x1. Okay, so for equation of straight line, okay, remember, for equation of straight line, what are the things that you need to have? A point. And of course, you need to have a gradient for that line. Okay, so from this equation, since we are talking about these two lines are parallel, so we know that when two lines are parallel, the gradients are the same. So if gradient line 1, let's say gradient line 1 is negative 1, let's say. So we know that gradient for line 2 is also negative 1. Okay, so we need to find the gradient for line 1 first. Okay, so find the gradient of the straight line. So from 2y plus 4x equals to 5, we change it into the gradient form. Y equals to mx plus c. Okay, change it into gradient form. Y equals to mx plus c. So we can say that, oh, our gradient is negative 2. Okay, So gradient line 1 is negative 2. Therefore, we can say that, oh, gradient line 2 is also negative 2. Okay, so next, we do have our gradient and we do have a point. So what are we going to do? Find the equation of the straight line by using the coordinate 1, 4 with the gradient of negative 2. Which straight line are we talking about? Okay, which straight line are we talking about? This straight line. Okay, this straight line. Okay, so by using this equation, by using this formula, y minus y1 equals to mx minus x1, we just substitute all the values. Okay, because 1, 4 is actually x1, y1. Okay, so we substitute the values and then we will have y is equals to negative 2x plus c. So what does y equals to negative 2x plus c? Equation of line 2 there. Okay, can you follow? Simple, right? Okay. Okay guys, let's look at perpendicular lines. Okay. So from here, we can say that this diagram, we have line 1 which is in green and line 2 which is in red. Okay, both lines will produce a 90 degree at C. Okay, so when we have two lines that intersect each other, two lines that intersect each other and form a 90 degree between the lines at the intersection point. So that is what we call perpendicular lines. So perpendicular lines is two lines. Oh, I need to change the color. Okay, two lines that intersect each other and produce 90 degree. Okay, in which usually we call it as normal line. Okay, which is the normal line? So let's say this is line 1. Line 2 is said to be the normal line. Okay, the line that perpendicular to the other line. Okay, so that is what we call perpendicular. Okay, or in Malay we say it as serenjang, garis serenjang. Okay, so we can say that, oh, since this is 90 degree, the angle CBA, angle CBA is equal to theta 1. Okay, so it is said that this angle is theta 2. Okay, as you can see here, theta 2 is equals to 90 degree plus theta 1. How can we say that theta 2 is 90 degree plus theta 1? Okay, so we have this right angle triangle. Okay, we have this right angle triangle. So what is angle CAB? Of course, angle CAB is 180 minus 90 degree and then minus theta 1, right? Okay, minus 90 degree and minus theta 1. Okay, so we can say that CAB is equals to 90 degree minus theta 1. Okay, how about theta 2? Okay, so let's use another color. Okay, so this part is CAB tadi. Okay, So how about theta 2? So theta 2, okay, so we know that, oh, this one, okay, this is theta 2. And then this one tadi apa? 90 degree minus theta 1. So of course, we know that the whole will give us 180. So theta 2 is 180 minus 90 degree minus theta 1, which give us 180 degree minus 90 degree plus theta 1. So our theta 2 is 90 degree plus theta 1. Okay, guys, can you understand? So that is why theta 2 is 90 degree plus theta 1, exterior angle of the triangle. So when we talk about gradient for line 2, okay, since theta 2 is related to this line 2, so when we talk about gradient, we are talking about tangent. So tangent theta 2 is equal to tangent 90 degree plus theta 1. Okay, tangent 90 degree plus theta 1. So basically, we said that, oh, tangent theta 2 equals to negative 1 over tangent theta 1. So how? Okay, let's look. Can you see, guys? Sorry. Okay. So how? So in ABC, triangle ABC, we said that tangent theta 1, tangent theta 1 is opposite over adjacent, in which opposite is AC and adjacent is BC. So let's use another color. Try this one. Okay. And then since we know that, okay, for tangent theta 2, opposite is BC and adjacent is AC. So BC over AC is equal to 1 over tangent theta 1. So we can say that, oh, tangent theta 2 is negative BC over AC. Okay, theta 2 here. Remember, when we talk about theta and trigonometry, we need to use acute angle. But this one is theta 2. Theta 2 is obtuse. So we need to find reference angle, in which our reference angle is here, theta alpha. Okay, alpha. Okay, so we can say that, oh, that means our tangent theta 2, okay, our tangent theta 2 is basically BC over AC. But why negative? Why negative? Because of previously we said that what? Benar nampak Okay, sama dengan. Okay. Previously we said that add sugar to coffee, right? So theta 2 is at quadrant 2. Add sugar to coffee. So quadrant 2, sugar, S. So only sign is positive. So that means tangent in quadrant 2 is negative. Okay, tangent in quadrant 2 is negative. That is why tangent theta 2 is negative BC over AC. So we claim that, oh, BC over AC ni apa? It's actually 1 over tangent theta 1. So this is negative. Why negative? Because tangent in quadrant 2 is negative. Okay, so that is why we have this one. Tangent theta 2 is equal to negative 1 over tangent theta 1. So from here we can say that, oh, tangent theta 1 times tangent theta 2 is equal to negative 1. Thus, since tangent theta 1 represent gradient line 1, so M1, and tangent theta 2 represent gradient line 2, so M1 times M2 is equal to negative 1. Okay. So Conversely, if m1 times m2 is negative 1, we can find that theta 2 is equals to 90 degree plus theta 1, and L1 is perpendicular to L2. So what I want you to know is, when we talk about line 1 perpendicular with line 2, so it deals with m1 times m2 is equals to negative 1. So m1 is the first line. So m2 represent the gradient for the perpendicular line, or we said that normal line. Okay, so from here, how can we find m2? So m2 is actually negative 1 over m1. Okay. Previously we said that parallel lines, when L1 parallel to L2, we need to know m1 is equal to m2. However, for perpendicular lines, when we talk about L1 perpendicular to L2, we need to know that the product of the gradients will produce negative 1. m1 times m2 must be equal to negative 1. Okay, understand? Okay, this is one of the proof for this concept, for the gradient for perpendicular line concept. Okay, next we are going to watch 2 videos that explain more in the proving. Okay.
What's up, everybody, and welcome to this lesson on parallel and perpendicular lines. We'll start off by saying that if 2 or more lines are parallel, then their slopes are the same, and we're going to go ahead and explore what that means. So let's look at 2 parallel lines graphed on the coordinate plane. We'll go ahead and plot a set of points on each line so that we can begin to find the slope. Notice that the rise for each line slope is going to be up 3 units. The run is going to be going to the right 5 units. So we can see that the slope for each line is going to be 3 over 5. Now, since these lines have the same slope, we can say that they are parallel because they are increasing at the same pace, and therefore, by definition, they will never intersect. However, if lines are perpendicular, that means that they form a right angle, then we can say that their slopes are negative reciprocals of each other. We'll also refer to this as flip and switch. So let's look at a set of perpendicular lines on the coordinate plane. Now let's notice how the green line has a negative slope. It's decreasing from left to right. We'll choose 2 points and calculate the rise over the run. We're rising down 6 units, and then we're moving over to the right 7 units. So the slope of the green line is negative 6 over 7. Now, since the purple line is perpendicular, the slope is going to be a negative reciprocal. And again, what that means is flip and switch. We take the slope of the other line, we flip it, and we switch the sign. So in this case now, it becomes positive 7 over 6. Now, you're probably asking, why did we do that? Let's take a look at the slope of the purple line now. If we go from point to point, we're rising up 7 units, and then we're moving to the right 6. And this negative reciprocal relationship between the slope of 2 lines will end up in those 2 lines being perpendicular to each other. So now we'll look at a few examples where we have the opportunity to apply these concepts. So on this graph, we are provided with a line S that passes through the points negative 4, 0, and positive 5, positive 2. We're also provided with a point J with coordinates negative 2, 4 that is not on the line. Now our goal is to construct a line that goes through point J that is parallel to line S. Now the word parallel should tip us off to thinking same slope. So we can go ahead and find slope the easy way just by calculating rise over run. We should notice that moving from point to point, we're moving up 2 units and to the right 9. So the slope of line S is 2 over 9. Now we know that our parallel line will have the same slope. So we're going to repeat that slope starting from point J by rising up 2 units and then running to the right 9 units and then plotting a new point. And finally, all we need to do is construct a new line through those 2 points that is parallel to line S with a slope of 2/9. Okay, let's look at a different example now. Here we have a line T passing through 2 points, -3, -1, and -1, +7. We have a point K that is not on the line, and we want to construct a line that is perpendicular to line T that passes through that point K. So when we see perpendicular, we need to think negative reciprocal slopes. So first we need the slope of line T. So let's go ahead and count the rise over run. Moving from point to point, we're moving up 8 units and to the right 2 units. Now we should recognize that 8/2 can be reduced to just 4 since 8 divided by 2 is 4. But we're going to write it as 4/1 because we want to think of slope as rise over run. Now again, the line we need to construct is going to be perpendicular, so we need a slope that's a negative reciprocal. So we'll take that 4/1 slope and we're going to flip it and switch the sign. So our new slope is -1/4. So all we have to do now is take that slope and build off of point K by going down 1 unit and then over to the right 4, plotting a new point, and then connecting those 2 points and drawing a line through them. That line will be perpendicular to line T and passes through point K.
Why do gradients of perpendicular lines give us a product of -1? Let us first begin with a straight line. Let's call it L1. And also create a right angle triangle using horizontal and vertical line segments. Let's call the horizontal line segment B and the vertical line segment A. With that, we can find an expression for the gradient of line, calling it M1. When we run B units from the left to the right, we find ourselves moving upwards by A units. Hence, M1 can be expressed as A over B. Now, let us duplicate this line, make a mesh, and rotate it by 90 degrees, so that it is perpendicular to the green line. Let's call this line L2. Now, you will notice that the measurements of the triangle has not changed. However, the vertical component is now B, and the horizontal component is now A. So now, let us find an expression for the gradient of L2, calling it M2. Right now, as we move A units from left to right, we find ourselves moving downwards by B units. Or in other words, we are rising by -B units. As such, the expression for M2 is now -B over A. M1 is A over B. M2 is -B over A. Multiplying the two together, we now see how easily the A's and B's cancel out each other, simplifying to a very nice -1. And hence we conclude this very simple proof of why the gradients of perpendicular lines give us a product of -1.
Okay, let's look at example 3. Okay, determine whether the following pairs of straight lines are perpendicular lines. Okay, determine, or in Malay we say it as tentukan. Okay, so if we want to determine perpendicular lines, before we said that if 2 lines are perpendicular to each other, therefore M1 times M2 must be equals to -1. So we need to fulfill this part. Okay, so of course again we need to have the gradient for each line. Okay, so we need to form it in the gradient form. Okay, next what will we do? Okay, again deals with M1 times M2 equals to -1. Okay, so for the first equation, 3y minus x minus 2 equals to 0. So as we can see, the coefficient of y is 3. When we talk about gradient form, the coefficient must be equals to 1. So what we are going to do, we need to divide both sides with 3. So we will have y equals to 1 over 3x plus 2 over 3. So if we compare with the gradient form, y is equals to mx plus c. So the gradient here is 1 over 3. Okay, so m1 equals to 1 over 3. How about the second line? Okay, so the second line, y plus 3x plus 4 equals to 0. So y is, the coefficient is 1, so just nice. So just change it into the gradient form. So we have y equals to negative 3x minus 4. So we said that, oh, our gradient is negative 3. So if I describe this situation, okay, the situation, so we have our straight line here. Okay, this is L1, in which the equation is 3y minus x minus 2 equals to 0. And then we have another line, this straight line. This is our L2, in which the equation of it is y plus 3x plus 4 equals to 0. So this is how it is described for both equations. Okay, so again, when we talk about perpendicular lines, the product of the gradients must be equals to negative 1. So the next step, of course, we need to find m1 times m2. Okay, so we need to find m1 times m2. So 1 over 3 is our m1 and m2 is negative 3. So 1 over 3 times negative 3, we have negative 1. Okay, we have negative 1. So since the product of both gradients is negative 1, therefore we can say that, okay, both lines are perpendicular to each other. Simple, right? So simple. Okay, this type of question is very easy. Okay, let's look at example 4. Okay, example 4. Find the equation of straight line which passes through 1, 4 and is perpendicular to line y equals to negative 2x plus 6. Again, when we talk about equation of straight line, okay, we are dealing with this. Oh, sorry. Okay, we are dealing with this equation. Okay, so let's describe the situation. Okay, so we have our line 1, y equals to negative 2x plus 6, and then we have another line. Let's give another color. Okay, we have this line 2. So this line 2, what is the equation? So that is what the questions talk about. Okay, so of course, since here we say that, oh, we need to have m. Okay, we need to have gradient, and of course we need to have point. So we have point here, so this is x1, y1. But since we are talking about the perpendicular line, so we need to know what is m2. Okay, what is m2? Because line 2 is the perpendicular line. Okay, so first of all, okay, again, when we talk about when line 1 perpendicular with line 2, so we need to know m1 times m2 must be negative 1. So since we talk about what is the value of m2, therefore m2 is equal to negative 1 over m1. So first of all, you need to find the gradient of the first line. Okay, so what is the first line? So the first line is y equals to negative 2x plus 6. So again, in gradient form, you can say that, oh, our gradient here is negative 2. So gradient m1 is negative 2. Okay, so what's next? Find the gradient normal of the straight line. So gradient normal of the straight line. Okay, this line 2 is also called as normal line because that line intersect with line 1 and form a 90 degree. Okay, so it means that gradient normal, so we are talking about m2. So m1 times m2 is equal to negative 1, therefore m2 is equal to negative 1 over m1. So negative 1 over negative 2, which gives us gradient normal m2 is half. Okay, is half. So we do have two important things in equation of straight line. We do have a point and we also have our gradient. Okay, what types of gradient? Gradient normal. Because of what? We are talking about perpendicular line. Okay, so we are talking about normal line. Okay, normal line equation. So, find the equation of the normal line by using the coordinate 1, 4 with the gradient of half. Okay, so just substitute all the values that we have in y minus 1 equals to m2 x minus x1. Okay, for me, personally, I rather use m1 and m2 so that I know, oh, m2 I am dealing with perpendicular lines. m1 is just the normal one gradient, okay, or parallel lines. Okay, so substitute all the values. So we will have y is equal to half x plus 7 over 2. So this is equation for line 2. Okay, simple, right? Okay. Okay guys, let's look at example 5. Okay, let's proceed. Okay, the diagram on the right shows a parallelogram ABCD. Points A and D are 1, 2 and 3, 6 respectively. Equation of straight line DC. Okay, equation of straight line DC. Let's look at our ink. What type of ink? Okay, tune. Okay, equation of line DC is 3y minus x equals to 15. Oh, there. Okay, DE is the perpendicular bisector of AB. So what is perpendicular bisector? A line that divides 2 points equally. Okay, so that means this one is equal to this one. So that means E is a midpoint. E is a midpoint. Okay. Okay, then find A, the equation for AB and DE, and B, the coordinates of E and B. Okay, let's look. Let's dig in. Okay, so the first question asks us to find the equation of AB. Of course, when we talk about equation of AB, so we need to have gradient and we need to have point. So we do have point. In this case, we have point A, which is 1, 2. So, gradient, we need to find the gradient of AB lah, kan? Okay, so since, okay, let's see here, DC is parallel to AB, so which give us MDC is equal to MAB. Okay, MDC is equal to MAB, so we need to find gradient of DC first. So DC is 3y minus x equals to 15. So we will have our gradient form for DC, y equals to mx by c. So we will have our gradient is 1 over 3. So gradient CD is 1 over 3. Okay, so that means if we have gradient DC or gradient CD, gradient AB will be the same, which is 1 over 3. Why? Because line CD and line AB are parallel to each other. Okay, so next. Okay, so we have point A, 1, 2, and then we have gradient AB is 1 over 3. So the question asks for equation. So when we talk about equation, so y minus y1 equals to mx minus x1 or m1 lah. Okay, so m1 lah. So substitute all the values. So at the end, we will have y equals to 1 over 3x plus 4 over 3. So what is this? This is equation line A, B. So y equals to 1 over 3x plus 4 over 3 represent equation of line A, B. Or if you don't like fraction, we can also state it as 3y equals to x plus 4. The same thing. Okay. Okay. So let's look at DE. Okay. AB, we have found the equation of AB. So what is equation of DE? Again, we know that the point for D is 3, 6, and the point for E, we don't know. So E is XY. But we know that E is midpoint for AB. So what is the sorry? So what is the formula for midpoint? X1 plus X2 over 2, comma, Y1 plus Y2 over 2. Okay, because midpoint we are talking about coordinates. So we know in order for us to find equation of DE, okay, first we need to find gradient. And we need to have a point. So, how can we find gradient? We need to find point E first. Okay, so gradient DE is equal to gradient AB. Oh, okay. Oh, I forgot. DE is perpendicular. It is stated here. DE is perpendicular to AB. Okay, so DE perpendicular to AB. So we can just connect it with M1 times M2 equals to -1, or we can find M2 is equal to -1 over M1. So since DE is perpendicular, so we can say that, oh, gradient DE is actually -1 over MAB. Okay, -1 over MAB. Okay, so if we substitute the values, we can say that, oh, gradient DE is -3. Okay, gradient DE is -3. Okay, so D is given 3, 6. So now equation, what importance for equation of straight line? We just need a gradient and a point. So we have both information. So just fill in y minus y1 equals to M2 x minus x1, because why? Because DE is perpendicular. Okay, so substitute the value. So at the end we have y equals to -3x plus 15. So what does this represent? Represent the equation of line DE. Okay, I hope you can understand for A. Okay, let's look for B. Okay, B, the coordinates of E and B. Okay, coordinates of E and B. Again, E is the midpoint. Okay, E is the midpoint. So, midpoint, let's say midpoint x1 plus x2 over 2, y1 plus y2 over 2. So this is the equation. Okay, so what can we find? Can we find by using this one? If we need to find by using the equation of midpoint, we need to have point B. Okay, we need to have point B, but we don't have point B. However, we can see that instead of E is a midpoint, E is a point of intersection between line AB and line DE. Okay, E is a point of intersection between line AB and line DE. So when we talk about point of intersection, so we are dealing with what method? We are dealing with simultaneous equation. Okay, so do we have equation for DE? Of course we have. Do we have equation for AB? Of course we do have both equation. So what you are going to do, you just need to apply simultaneous equation. Okay, so from here AB is y equals to 1 over 3x plus 5 over 3. DE is y equals to -3x plus 15. Since both equation, the subject is y, so we can say that, oh, that means 1 over 3x plus 5 over 3 is equals to negative 3x plus 15. Because what? At point E, for both lines, the point is the same. X and Y is the same at the point of intersection for both lines. Okay, so we settle up the linear equation. So we will get our x is equals to 4. So E is in terms of x and y, so we have our x, which is 4. Next, what we are going to do, we need to find the value of y. So how? Just substitute x either in equation AB or equation DE. Never mind. So I choose AB because AB is not, so I choose AB. Okay. So when we substitute 4 in AB, so we will have the value of y coordinate is 3. Thus, we can say that, oh, this the coordinate for E is 4, 3. So now we have 4, 3. Okay, let's see. Okay, so this is A. Okay, this is A12. And then this is our B, which we don't know, x2, y2. And then this is our E, 4, 3. So this is equal. So now, how can we find B? Of course, we can use the midpoint formula. Okay, we can use the midpoint formula. Okay, so since M, or in this case M is represented by midpoint. So in this case E lah. Okay, in this case this is E. Okay, in order for us to find midpoint, x1 plus x2 over 2 and then y1 plus y2 over 2. So we need to substitute all the values. Okay, when we substitute all the values, so as you can see, this is x, this is y, and this is also x, and this is also y, relate with equal sign. So from there, I can say that, oh, the x for left hand side will be equal to x in the right hand side. Same goes to y in the left hand side will be equal to y to the right hand side. So this is where this comes from. So 1 plus x 2 over 2 is equals to 4, because this is equal to this, and this one is equal to this one. Okay, same goes to y. 2 plus y2 over 2 is equals to 3. So solve the value of x2. So we have x2 equal to 7 and the value of y2 is equal to 4. Therefore, our point B is 7, 4. Okay, so in solving this type of question, you need to be creative. Okay, you need to be creative. You need to generate the ideas and use all the information given and use all the knowledge that you know in coordinate geometry. Okay, I hope you can understand. Okay, let's look at solving problems question. Okay, example 6. Okay, we have diagram here. Okay, the diagram shows on the right the position of AD, BC and EF drawn on a Cartesian plane. So AD and BC are perpendicular with each other. AD and BC are perpendicular with each other. Okay, so 90 degree there, and they meet at traffic light junction, while BC and EF are parallel to each other. So parallel to each other. Okay, given that the coordinates of A 18, 16, and then F 20, -1. Okay, and then the equation of BC Okay, equation of BC is 5y plus 4x equals to 70. So find the equation of root EF, equation of root AD, and coordinates of the traffic light. Okay, so here, first of all, we need to understand the problems. Okay, so from the question, we know that root AD and BC are perpendicular to each other. Okay, AD and BC perpendicular to each other. So when we talk about perpendicular each other, so we need to apply M1 times M2 equals to negative 1. And then root BC and EF are parallel to each other. So we know that M1 equals to M2. So we said that gradient BC will be equal to gradient EF. Okay, so coordinates of point 18, 16, 20, negative 1 of the equation of root BC. Okay, so please at the diagram you write down all the information given. Okay, so it's easier for us to see clearly and to solve the question. Okay, and then find the equation of EF, okay, and AD, as well as the coordinates of traffic lights. Okay, coordinate of traffic lights. So this one. So coordinate of traffic lights here is actually the point of intersection between line AD and BC. Okay, so that's the thing. Okay, next step, what are we going to do? Plan the strategy. Okay, so write the equation 5y plus 4x equals to 70 in the gradient form to find gradient M1. Okay, of course. Okay, of course. First of all, find gradient 1. Okay, and then since BC and EF are parallel, we said that M1 equals to M2. So if you find gradient BC, you will find gradient EF. Okay, and then use formula M1 times M2 equals to negative 1 to find the gradient of root AD. Okay, why? Because AD is perpendicular to BC. So again, if you have BC, you can also have the gradient of AD, but you need to apply M1 times M2 equals to negative 1. Next, use formula y minus y1 equals to mx minus x1 to find equation of roads EF and AD. Of course, we are talking about equation of straight line. So use y minus y1 equals to mx minus x1. And then solve equation 5y plus 4x equals to 70 and the equation AD simultaneously to find the coordinates of the traffic lights. Why? Because previously I told you that the traffic light is the point of intersection between line AD and BC. So when we talk about point of intersection, how can we solve the matter? By using simultaneous equation. Okay, so again, point A is 18, 16, F is 20, negative 1, and then this one is 5y plus 4x equals to 70, and this is our 90 degree, and this is this. Okay, so from here we said that MBC is equals to MEF. Okay, however, MAD is negative 1 over MBC. Okay, let's change color. Okay, so next, sorry guys. Okay, so this is what we have. Okay, this is what we have here. Okay, so let's go to the next step. Okay, implementing the strategy. Okay, so before we said that, we need to find the gradient of BC, which is M1. Okay, so from equation BC, we can have gradient of BC by forming it into gradient form. Y equals to mx plus c. So we need to change it into y meh? Okay. Y. Okay, doesn't matter. Okay, we need to change it into y equals to mx plus c. Okay, so we have y equals to negative 4 over 5x plus 14. So we said that, gradient 1 or gradient BC is negative 4 over 5. Okay, so now we need to find a equation of root EF. Okay, since gradient of BC is equals to gradient of EF here. Okay, so since gradient of BC is equal to gradient of EF. Okay. Okay. So we said that the equation, in order for us to find equation, we need to have a point and the gradient, right? So we have our point F, 20 negative 1, and we have our gradient of EF, which is negative 4 over 5. So substitute in the equation y minus y1 equals to m1 times x minus x1, in which at the end we will have 5y plus 4x equals to 75. So that is our equation of EF. Okay. So for B, the equation of root AD. Okay, AD is perpendicular to BC. Okay. So before, when we talk about perpendicular, M1 times M2 equals to negative 1, in which M2 is equal to negative 1 over M1. So in this case, M2 is represented by gradient AD and M1 is represented by gradient BC. Okay, so since this one is okay, so we have our gradient 2 or gradient AD. So gradient AD is 5 over 4. Okay, so now we have our gradient normal. Okay, gradient normal, which is 5 over 4. So what is our point? So since we are talking about equation of AD, we use point A. Okay, we use point A. Okay, we use point A. Okay, we use point A. So now we have A, 18, 16, and then we substitute our A and our gradient in y minus y1 equals to m x minus x1. It's just that this one m2, because of what? Because we are talking about gradient normal, or we are talking about equation normal, the perpendicular lines. Okay, so just substitute all the values. So we will have 4y minus 5x equals to negative 26, or we can also write it as 4y times, 4y is equal to 5x plus 26, y is equal to 5 over 4x plus 26 over 4, so 13 over 2. Can also, okay, you can you can write it as gradient form. Okay. Okay. Next, for C, the coordinates of the traffic light. Okay. Again, traffic light is point of intersection between AD and BC. So when we talk about point of intersection, we are talking about solving by simultaneous equation. Okay. So this is our first equation, 5y plus 4x equals to 70. And then our equation of AD is our second equation, 4y minus 5x equals to negative 26. So equation 3, we change both equation in which we are making x to have the common coefficient. Okay, so equation 1 times 5 and equation 2 times 4. So we will have this equation 3 and equation 4. So now what we are going to do is we need to eliminate x becoming 0. So how can we make x becoming 0? By adding equation 3 and equation 4. So what remains is 41y is equals to 246. Thus we have our y equals to 6. Next, substitute y equals to 6 in equation 1. Why? Because we need to find x. Okay, so we will have x equals to 10. So our coordinate for traffic lights is coordinate 10, 6. Okay guys, I hope you can understand. Okay guys, let's move on with example 7. Okay, let's look at example 7. Okay, diagram on the right, radius AB of the Ferris wheel is perpendicular to the tangent. So this is our radius and this is our tangent. Oh, this is our tangent line. Okay. Okay. So when we have a line that touches a tangent at one point, in which this point is B at 12, so there will be 90 degree between that line. So we can say that the radius and the tangent line are perpendicular to each other. Okay, so the equation of the tangent to the circle at point B is given by, okay, this one is given by 3x plus 2y equals to 48. Okay, find the equation of radius AB. Find the equation of radius AB. So we need to find equation, okay, for this line, okay, of the Ferris wheel. Okay, so let's look. Okay, so first of all, of course, when we want to find equation, so the two things that we need to have is a point. In this case, we have point B, which is 8, 12. But the other one, we need to find gradient. Okay, gradient. So since this equation, we don't have the equation of radius and we don't have the gradient for the equation of radius. Okay, but from tangent line, we can have our gradient. Because of what? Because we have our equation of the tangent line. So first of all, find the gradient of the tangent, in which in this case M1 lah. Okay, so this is our L1 and this is our L2. Okay, so when we compare it with our y equals mx plus c, okay, our gradient form, so we can say that, oh, our gradient for tangent line or our gradient tangent is negative 3 over 2. So M1 is negative 3 over 2. So next, okay, so we have here negative 3 over 2 is equals to M1. So we need to find the line that is perpendicular to the tangent line, which is the line of the radius. So we are talking about gradient normal here. We are talking about equation normal. So we deals with gradient normal. Okay, M2. Okay, so this is normal line, normal line. Okay, so we are talking about M2. So in this case, okay, again, when L1 perpendicular with L2, so we need to know M1 times M2 is equal to negative 1. So we can say that M2 is equal to negative 1 over M1. So we need to find M2. Okay, so M2 is equal to gradient AB. Okay, M2 is equal to gradient AB. So M2 is also negative 1 over M1. So M2 is 2 over 3. M2 is 2 over 3. So now, can we find our equation of straight line for AB? Of course we can, because we have our point, which is B. And we also have our gradient normal, which is M2, which is 2 over 3. So just substitute in y minus y1 equals to M times x minus x1. Okay, so just fill in the values. So at the end, we will have y equals to 2 over 3x plus 20 over 3, or you can also write it as 3y equals to 2x plus 20. So what is this? This is equation of AB, or equation of the normal line. Simple, right? Okay, next, let's look at example 8, the last example if I'm not mistaken. Okay, so diagram on the right is a plan of a rectangular shaped hut drawn on a Cartesian plane. A pipe of the shortest length will be connected from the main pipe at P. So this is the main pipe. Shortest length. So when we talk about shortest length, we are talking about straight line that will touch the line AB and will form 90 degree. In other words, we are talking about normal line. Okay, normal line. So the concept of perpendicular is involved here. Okay, so find A, the coordinates of point of connection of the pipe at the height. B, the length of trench that should be dug in order to bury the pipe to the height. Okay, let's look at A. Find the coordinates of point of connection of the pipe at the height. So we need to find here. So basically we are talking about the midpoint. Okay, the midpoint. So again, okay, when we talk about midpoint, x1 plus x2 over 2, y1 plus y2 over 2. So just substitute all the values for A and B in the formula. So we can say that, our midpoint M is coordinate 5, 5. Okay, coordinate 5, 5. Okay, let's look at B. The length of trench that should be dug in order to bury the pipe to the height. The length of trench that should be dug in order to bury the pipe to the height. So, what we are dealing with? We are talking about this length. So, we are talking about PM is equals to what? Okay, PM is equals to what? So, we are talking about distance. Okay, distance PM. So, M, we know that M is 5, 5, P is 8, 7. So, since we are looking for distance for PM, you use the distance formula. Okay, just use the distance formula. So, fill in the formula. So, we will have MP is 3.606. Okay, you need to understand the question you need to read the question carefully and understand it so well. Okay, Okay, you need to relate it. Okay, you need to relate it. Okay, shortest distance, like the first A, shortest distance, so normal line. Okay, and then the length of the trench from P to the height, so PM. We are talking about distance. So relate lah. Which one is suitable? Okay. Okay, I hope you can understand. Okay, next, our evaluation time. So this is your question. Okay, I want you to try on your own. And of course, at the end of the class, you need to discuss these questions, your answer with your teacher. Okay, the next part, homework. Okay, so I have few homeworks for you. Okay, self-practice 7.4, all questions. Intensive practice 7.2, all questions also. Okay, so guys, remember, before I end up our lesson, remember, parallel lines. Two lines is said to be parallel if the gradients are equal. L1, okay, remember, L1 parallel to L2 if and only if gradient 1 is equal to gradient 2. However, when we talk about two lines perpendicular to each other, that means the product of both lines, the product of the gradient of both lines will give us negative 1. Okay, and then so that means M2 is equal to negative 1 over M1. Okay, again, when we talk about equation of straight line, what you need to have is a point, and then we need to have gradient. Okay, it depends. Gradient 1 is the normal gradient and gradient 2 is the gradient normal, the perpendicular line. Okay, so substitute in y minus y1 equals to m times x minus x1. Okay, so these things are important. And of course, again, your final answer should be at least 4 significant figures and 2 decimal places. Okay, next. The last part. A problem can be real, but it is your choice whether you want to stay in it or you get out of it. Okay, before I end up my session, I wish you all the best and good luck. I end up with Assalamualaikum warahmatullahi wabarakatuh and peace be upon you.